All right, my mathematicians, we are back with section 5 of chapter 3, which deals with arithmetic sequences and linear functions. Now, before we identified linear functions, and now we are going to recognize arithmetic sequences and relate arithmetic sequences to linear functions. Now, here's some vocabulary. We're going to talk about what a sequence is, the terms of a sequence, arithmetic sequence, and common difference. So in the setup here, we have during a 2,000-meter race, the coach of a women's crew team recorded the team's times at several intervals. At 400 meters, the time was 1 minute 32 seconds. At 800, it was 3 minutes 4 seconds. 1200, 4 minutes 36 seconds. And 1600 meters, it was 6 minutes 8 seconds. They completed the race with a time of 7 minutes 40 seconds. So you can relate the pattern of team times to linear functions. A sequence is a set of numbers but called the terms of the sequence in a specific order. Look for a pattern in the information given for the women's crew team. Make a table to analyze the data. So the distance is going to be here, and the time in minutes and seconds is here. Now, if we notice, each time it goes up by 400 meters, there's an additional minute and 32 seconds added to the time each time. Now remember, seconds, there's 60 seconds in a minute, so we're not going up to 100 to get the next minute. We're only going up to 60. So if you add a minute and 32 seconds to a minute and 32 seconds, you're going to get 3 minutes and 4 seconds. If you add a minute 32 to that, you're going to get 4 minutes and 36 seconds. Just wanted to kind of point that out for you there. Okay, so as the distance increases in regular intervals, the time increases by 1 minute and 32 seconds. Since the difference between successive terms is constant, in other words, it goes up by 1 minute and 32 exactly each time, this is an arithmetic sequence. The difference between terms is called the common difference. So for a sequence to be an arithmetic sequence, the numerical pattern has to increase or decrease at a constant rate, which is called the common difference. Now, it can increase or it can decrease. In our examples here, this 3, 5, 7, 9, 11 goes up by 2 each time because the next term is 2 more than the previous one. Likewise, this one goes down for each successive term because the next term is 4 less than the previous term. And the easy way to do this, to figure it out, is to just subtract the first term from the second from the third from the fourth, just to see what the difference is between the terms. Now, the 3 dots used with a sequence are called an ellipsis. The ellipsis indicates that there are more terms in the sequence that are not listed. So that means basically it just continues in the same pattern. So determine whether each sequence is an arithmetic sequence and then explain. So for this one, if you notice that if you find the difference between each of the successive terms, it goes up by 2 each time. So the difference between the terms in the sequence is constant, therefore this sequence is an arithmetic sequence. This one, from 1/2 to 5/8, now what you'd have to do there to figure that out is just do 5/8 minus 1/2. Now you'd have to convert this to a fraction over 8, so 5/8 minus 4/8 is 1/8. And that's where they got this plus 1/8, okay? And then they did the same thing. They did 3/4 minus 5/8, saw that it was 1/8. Now you might be tempted, oh, it was 1/8 both times, therefore it's an arithmetic sequence because they have the same common difference, or they have a common difference. Well, if you do all the terms that are given, which you should do just to make sure, you'll find that the difference between the third pair of terms is not the same as the first two. Therefore, since the difference between the terms is not constant, this is not an arithmetic sequence. Okay, so here's 2 for you to try. Go ahead and pause the video and hit play when you're ready to check your answer. All right, we're back. So this one goes up by 4, up by 4, up by 4. So since all the common differences are the same, that means the terms in the sequence increase by a common difference, therefore it's an arithmetic sequence. How about this one? Here you go, plus 3, here you go, plus 5, and here you go, plus, is that 16, right? Well, basically you just had to find out that the first two didn't have a common difference, and therefore all you need is just one to not be the same, and it breaks it. So therefore, since there is not a common difference, this is not an arithmetic sequence. Okay, so we can use the idea of the common ratio if we have a arithmetic sequence, we know something's an arithmetic sequence, then we can use the common difference to find more terms of it. So if I want to find the next 3 terms of this arithmetic sequence, I first have to find out what the common difference is. Notice the terms are decreasing, so the common difference is going to be negative, and each time it goes down by 6. So all you do is just keep adding -6 or keep subtracting 6 from the terms. So to find the next 3 terms, we start with the last one they gave us, -3, and then subtract 6 3 more times. So -9 minus 6 is -15, minus 6 is -21. So the next 3 terms in the sequence are -9, -15, and -21. Pretty cool. All right, now one for you to try. Go ahead and pause the video and hit play when you're ready. Okay, we're back. So you'll see that the common difference here is plus 1.5. So if I start at the last term they give me and add 1.5, I would get 15.5. And then add 1.5, I get 17.0. And then if I add 1.5, I would get 18.5. So the next 3 terms are 15.5, 17.0, and 18.5. Alrighty? All right, good. Going good so far. So each term in an arithmetic sequence can be expressed in terms of the first term in the common difference D. The first term we denote with an A with what's called a subscript of a 1. It's kind of like, if you had a squared, you put the exponent as a little small number up top on the right side of the variable or the letter or the number, whatever it is. Well, a subscript you put below the number, a little bit smaller. Like subway is underground. Well, a subscript script means like a letter or number writing, and you just put it a little bit lower on the number there. So the number for the subscript represents the term that you're on. So the first term is a sub 1. The second term is a sub 2. The third term is a sub 3. Now, if the first term is 8 and the common difference is 3, okay, let's say the common difference is 3. Well, to get the second term, you take the first term and just add the common difference. So 8 plus 3 is 11. To get the third term, how you can think of it is you have to add 3 again. So far you've added 3 2 times to the first term. So it's A1 plus 2 times the common difference, or 8 plus 2 times 3. The fourth term, same thing. You're going to have the first term, which is A1, and then to get to the fourth term, you're going to have to add the common difference 3 times. So you can think of it in terms of the first term as A1 plus 3 times D, or 8 plus 3 times 3 is 17. And you keep on going in that pattern. So really, you can figure out any term you want as long as you know the first term and the common difference. And how you can explain it is that any term is equal to the first term times the common difference, or plus the common difference times the number of term that you're on minus 1. Now, the reason it's minus 1 is notice that each time we multiplied by 1 less than the number of term that we were on. Because to get the first term, you know that. You don't have to add the common difference. But to get the second term, you add the common difference once. To get the third term, you add it twice. To get the fourth term, you add it 3 times. To get the seventh term, or 3 times. To get the seventh term, you add it 6 times. To get the nth term, any term you want, you take the original term and add to it 1 less than the number of term that you're on times the common difference. Okay, so the nth term of an arithmetic sequence with the first term a sub 1 is the common difference, and the common difference, D, is given by a sub n equals a1 plus n minus 1 times d, where n is a positive integer. So here we want to write an equation for the nth term of the arithmetic sequence. So got to find the common difference, make sure it's an arithmetic sequence, and you'll notice that each time it goes up by 4, so plus 4 each time. So my equation is an equals a1 plus the quantity n minus 1 times d. I know that a1 is negative 12, and the common difference is 4. So this is the equation right here. Now I can simplify that by distributing the 4 and combining like terms. So if I distribute the 4, this becomes negative 12 plus 4n minus 4. Then negative 12 and the minus 4 can combine, and you get 4n minus 16. Now I can find any term of the sequence I want by just plugging the term number in for n. So if I want to find the 9th term, I just substitute 9 in for n, and 4 times 9 minus 16, 36 minus 16 is 20. So if I continued this out and just kept adding 4 to get to the 9th term, it would come out to be 20. But once I know the formula, I can just plug the term number into the formula to figure out what that actual term would be, which is really nice if you're trying to find, like, say, the 500th term. You don't have to keep adding 4 all the way up till you get to the 500th term and then lose track and forget, blah, 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 blah. Here, once you have the equation, you just plug the number in and you're done. Okay. Also, what we can do is graph the terms. So I know the first 4 terms, 1 through 4, they were given to me. And then the 5th term, I can use the formula, plug in 5, or just add 4 to get the 5th term. And now what you do to graph it, you use n, the term number that you're on, as your x value, and the actual value of the term as your y value, and make ordered pairs out of those. So if I plot them, 1, negative 12 would be here, 2, negative 8. Now, here's the thing. These are discrete functions, which means they are a collection of points that are disconnected. So you would not draw a line through there, because if you drew a line through there, it would imply that all the points in between these the blue dots here are part of the sequence. But the sequence is just individual numbers. It's not all the numbers in between. So it goes negative 12, negative 8, negative 12, negative 8. There's nothing in between there. There's nothing in between negative 12 and negative 8 in the arithmetic sequence. So when you're graphing arithmetic sequences, do not connect the points. Just plot them. Now you can plot more points if you want. That wouldn't be wrong. But don't connect the points. So which term of the sequence is 32? Now this is a little bit of a weird question. It's not asking what the 32nd term is, it's asking which term would produce 32. So that's actually giving you the an, and now you're trying to figure out which term it would be. It's kind of like, what's the value of x when y is 32? So you put 32 in for your an, add 16 to both sides, divide by 4, and you get n equals 12. Okay? All right, here's one for you to try. Go ahead and pause the video, take a couple minutes to answer the questions, and hit play when you're ready. Okay, so we're back. So this one, if I want to write an equation, I got to find the common difference. I know that a1 equals 3. So if I go up 13, that's going to work. So d equals 13. So an equals a1 plus n minus 1d. So a1 is 3, and d is 13. Actually, it's negative 13. I don't know why I put plus. It's minus 13. So make sure you put this negative 13 in parentheses here so you don't think it's n minus 1 minus 13. So distribute it, and you would be 3 minus 13 n minus plus 13. So an would equal negative 13 n plus 16. The 15th term, you're just going to plug 15 in here. And when you multiply that out, you would get negative 179. So if I want to graph the first 5 terms of the sequence, so I know the first 4, the next one's going to be negative 49. So if I begin to graph that, so the first term is 3, which is like right about there. The second term is negative 10. The third term is negative 23. The next one is negative 36. And the next one's negative 49. Now remember, I'm not going to connect those with a line because they are just terms. They're not everything in between. Okay? Which term of this sequence is negative 114? So put negative 114 in for the AN, and that's going to equal negative 13N plus 16. So you subtract 16 from both sides to get negative 130 equals negative 13N. Divide both sides by negative 13. You get N equals 10. So the 10th term of the sequence is negative 114. All right? All right, well, that's it for this video. In the next one, we're going to talk about arithmetic sequences and functions. So go ahead and hop on to the next video, and I'll see you there.